Assalamualaikum and hi everyone and welcome to this lecture. So first of all, I would like to ask you, have you ever written a program, excitedly hit the run button and then absolutely nothing works? If that things happen, welcome to the true programming experience. Today we are tackling a rite of passage for every developer, which is dealing with mistakes. Our topic for this session is common programming errors. By the end of this lecture, you will understand what debugging is. You will be able to identify the three main types of errors in C programming, and you will learn how to spot exactly where things went wrong. So if you take a look at the title slide and also look at the animation on the screen of the programmer happily rolling in his chair. So when our code works, this is exactly how it feels. But before we get to that stage, we usually have to do a little bit of cleaning up. So first, let's define our main term for the day. So look at the sweeping animation. Debugging is like cleaning up. Okay, so debugging is simply the process of removing errors from a program. When you are writing in C, there are three main kinds of errors you will encounter. First, we have the syntax errors. Second, we have runtime errors. And third one, we have the logic error, which is sometimes also called a design error. So can anyone guess which of these three is the easiest to fix? So keep that in mind as we go through them one by one. We have all seen screens like this, okay, the error messages popping up, or even a loading bar that just gets stuck forever. So these visual cues usually mean one of our three errors has occurred behind the scenes. Let's break them down one by one, starting with the most common error, beginners face. So our first category is the syntax error. Think of programming languages just like human languages. As we have rules for our language, so does the programming languages. Syntax errors are mistakes caused by violating the grammar of C. So the great news about syntax errors is that the C compiler can easily diagnose them during compilation. So when you make a grammar mistake, your code statement cannot be translated by the computer, and therefore the program cannot be executed at all. In a simple way, it means it simply refuses to run until you fix the error. Let's look at an example in our code blocks IDE. So we have a very simple program here trying to print the phrase "Hello World" to the screen. But if you look at the build messages, okay, at these logs and others part here, you can see at the bottom of the screen here, the build messages, you can see a bunch of red text. Okay, the red text. The compiler is actually yelling at us. So that's the meaning behind those text in the red colors. So it highlights line 5 here and says error expected before return. So take a look at this line here, error expected semicolon before return. So because of this, the build failed with 6 errors. So if we look closely at the arrow here pointing to line number 5, the mistake becomes obvious. You can see there is no semicolon at the end of the printf statement. In the C language, a semicolon acts exactly like a period at the end of an English sentence. So without semicolon, the compiler gets confused and doesn't know where the command ends. So you just need to simply adding that semicolon that will fix all those red errors instantly. Moving on to our second type of error. Sometimes you write a perfect grammar, you get past the compiler, the program starts running, and then suddenly, boom, a pop-up appears saying a runtime error has occurred. So what exactly triggers this error? The runtime error is a bit trickier because the C compiler cannot recognize it during compilation. Even the grammar was perfect. Instead, this error represents an attempt to perform an invalid operation, which is only detected during program execution. It occurs when the program directs the computer to perform an illegal operation, such as dividing a number by 0. So when the computer hits this illegal wall, it will immediately stop executing the program. It then displays a diagnostic message that indicates the exact line where the error was detected, so you can go investigate. So let's look at a code example of a runtime error. Here we declare two integers, salary and full salary. Then we ask the user to type in their salary. Welcome to Unimap. Enter salary. So the user will type in their salary using the scanf function in the statement, and the program will read it. Then the program tries to do some math before it ends. So take a look at the arrow pointing to our math equation. The formula says full salary equal salary divided by 0. So what happens mathematically when you try to divide anything by 0? Okay, you will not get answer for that because it's undefined. The compiler didn't catch this because division is a valid grammar rule in C. So if you put a slash forward here, the C will assume it's a division. But in mathematical equation, anything divided by 0 will be undefined. So when the computer actually tries to calculate it, it realizes it is impossible and make the whole program crashes. So this is actually a classic runtime error. Move on to the logic error. So this is the logic error. It is universally considered the most difficult error to recognize and correct. So why is it so hard? Because it does not cause a runtime crash and it does not display any helpful message errors on your screen. Your program compiles perfectly and it executes successfully from start to finish. But the final answer it gives you is completely wrong. So this is dangerous. Alright, so the computer did exactly what you told it to do. The problem is that your logic was flawed. So the actual problem is you do everything right and it didn't detect or display or give you any helpful message regarding errors present on your screen. And why is that? It's because the problem might be that your logic was maybe inconsistent or weak or imperfect, or there's something flawed in your code. Okay, let's look at an example here. So we have a program that asks the user to enter salary, just like before from this statement. And then it prints out a net salary. If you look at the black console window here, the user entered 5,000, but the output says net salary is 8. So how come it is put here as 8? So where did the number 8 come from? Because the user input the value of 5,000 as the salary. So this process, or what this value display, the math makes no sense. So the issue here is highlighted by the red arrow here. So we are printing the wrong variables, okay? Meaning the display output should be the value of the same value when the user as what the user has input earlier. So if you look at the code, we declared net salary here at the top, but we never actually wrote an equation to calculate it. So there's no calculation or equation in this code. So because of that, it is completely uninitialized. Then on line number 8 here, we already put the printf function, meaning we told the computer to print net salary anyway, okay? Because the net salary had no assigned value, it just printed a random piece of garbage memory, which happened to be the number 8 here. So there is no error message pop up because C actually allows you to print uninitialized variables. So with that, it just gives you a logically incorrect result. So no issue with the grammar here. Semicolons are there, perfect grammar, and no illegal maths way written in the code, so it's okay. But there's no logic here. We have the net salary variable with no assigned value, and we certainly doesn't have any equation written in this program code. But we have the printf function to print the net salary. So instead of what user input to be 5,000 here, the output of the actual output, the final one, the net salary is not showing the value of what the user has input, but actually gives the random number in the memory of the garbage. All right. Now that we have covered all three, let's test our knowledge with a real past year question from the 2016 and 2017 final exam. So the question asks you to define these three terms, okay? The first one, syntax errors, then runtime errors followed by logic errors. So this question is worth 3 marks. So try to take a brief moment and think about how you would answer this on a test. Okay, how to define all these 3 terms as if you are answering the final or test. Okay. So to get the full 3 marks, here is what you need to write. For syntax errors can be defined as mistakes caused by violating the grammar of C. The C compiler can easily diagnose them during compilation. So that's the definition for syntax errors, 1 full mark. So for runtime errors, these are also called semantic error or smart error. They are a violation of rules during program execution, such as, for example, that we have going through is the division by 0, and the C compiler cannot detect the error during compilation. For logic errors, this is the most difficult error to detect and correct. The program compiled and executed successfully, but produced incorrect results. So basically, if you are facing with the logic errors, you need to check the code line by line, because incorrect result is the result from the incorrect logic of your coding writing. So meaning, which is why from previous lecture, it is important when you are given a task or question, you need to plan what are you going to do first through algorithm, which are pseudocode and flowchart. That is the right way and best practice. So look at our rotating Mario question block here. It means we have reached the end of our material for this particular chapter. So if anyone does have any questions about the 3 types of errors we discussed today, or any other topic or subtopics we have discussed from before and up till today, please let me know in the class or out of class, no problem. So to summarize what we have learned today, debugging is a massive part of being a programmer. It is completely normal to make mistakes. Remember the 3 distinct types we have covered. First, watch out for syntax errors. Always double check your grammar and make sure you are not missing any semicolons, alright? And second, be mindful of the runtime errors. Prevent your program from attempting illegal maths like dividing by 0, which will crash your execution. The good thing about syntax errors and runtime errors, they can always give you alert or messages regarding the errors occurred. Not for logic errors. For logic errors, always trace your variables carefully to avoid it, because the computer will not warn you when your math or logic is simply flawed or imperfect or incomplete. So for your own practice, I would like you to try making these errors. Try to write any code. You can simply write back from the code examples given in the slides in your code blocks IDE and read the messages the compiler gives you. Understanding how the compiler talks to you is the fastest way to become a great debugger. Thank you all for your attention, and I'll see you in the next lecture for AI assisted code writing. Assalamualaikum.